Hello and welcome to this presentation on the retrofit of a cavity wall home. So this is delivered by March's Energy Agency as part of the Heat Hub project that ran from April 2023 through to March 2025. So firstly, starting off with some introductions. So my name's Ben. I'm the Technical Services Manager at March's Energy Agency. I'm a qualified retrofit coordinator, as well as having a background in architectural design. And March's Energy Agency is a charity specialising in fuel poverty and the decarbonisation of housing. And we work across Shropshire, Herefordshire, Telford and Wrekin, the Black Country, and Derbyshire as well. And we have now over 26 years of experience working within the energy sector with nearly 50 members of staff. And you may know us by a few other titles of the projects that we run or partner with, which could include Telford Energy Advice or T, Keep Shropshire Warm, or Warmer Derby and Derbyshire. And as I mentioned earlier, this presentation is coming to you via the Home Energy Advice Team Hub project. We're partnering with Nottingham Energy Partnership in the delivery of this, and we specifically support on the delivery within Derbyshire. So first off, I wanted to kick off with what the benefits of retrofit as a whole before we dive into the specifics of what kind of retrofit approach you might take on a kind of modern cavity wall home. So there are many benefits to it. One is improving your comfort through draft proofing and getting rid of those pesky drafts, improving your thermal performance, and reducing the heat demand of your property, which then in turn will lower your energy bills as well as lower your carbon emissions or potentially even bring you to zero carbon if you can achieve it. It increases your energy security as well, particularly if you're going for green technologies such as solar panels and batteries. Improve damp and mold and mitigate these issues through better ventilation, and through that also improving your health and well-being through having a warm and comfortable home, which is really, really important. So there's many benefits to retrofit as a whole, whichever home that you might live in. And in terms of this project, the Heat Hub project, we're covering or are covering quite a number of bases. So there's a big piece around raising awareness and education and delivering retrofit advice, particularly in person, as well as being able to scale up and push forwards the retrofit agenda to be able to decarbonise across the UK and look at what we can do in Derbyshire. So we've been running various educational events and webinars, practical workshops as well, signposting to grants and green finance options that are available, delivering retrofit surveys and tailored home retrofit plans, which I'll touch on in a bit more detail in a moment. Installer engagement and working with the supply chain to build that up, as well as publishing resources and case studies on best practice of what we're seeing in the region. And if you are watching this webinar before the end of March 2025, then I want to take this moment to promote our package of support that we're offering to give bespoke one-to-one advice to homeowners that are interested in retrofitting their own home. So this package is basically a retrofit assessment or survey and a report of recommendations to follow up with that to give you tailored advice and guidance as to how you could go about improving your home to decarbonise, to lower your energy bills and to improve your comfort as well. So the process would be that when you fill out an application form, a questionnaire would be given to you so we can understand your priorities as an individual and your wishes for your home. We'll then do a visit and a detailed survey will be conducted analysing the thermal performance of your property, which may include some thermal imaging and also carbon dioxide level monitoring as well. Then from that, a detailed report will be written up and shared with you, setting out energy efficiency works that you can do to your home in manageable stages in accordance with any budget or any other restrictions that you may have provided to us as well. And then from that point, we don't just want it to end there. We want to be able to support you in actually getting that retrofit done. So we'll give guidance and signposting to where you can find local contractors and installers to actually enable you to do that work. So this is in total over £800 worth of support and service that you could get completely fully funded through the project. So if you are watching this before the end of March 2025, then do jump on this opportunity because we do have some spaces left to do assessments and surveys. So go to our website and you can put an application form, and that will give you details around the criteria, as this project has primarily been focused around properties that are hard to treat in some way, whether it's because you have planning restrictions or it's a very low EPC, or maybe it's a heritage property and that has kind of challenges around that too. So without further ado, let's dive into the real content of this presentation. So in the live version, this will be interactive, but as it's just me and you're watching this recording, I'll be tweaking how I go in this presentation. So what you're seeing is two different patterns of wall. One is solid brick and one is cavity. And those of you with a bit of knowledge around this will have known that the one on the right, or at least the right on my side, with the changing pattern, is the solid wall, and the one with the consistent pattern is the cavity wall. So how do you know if you have a solid or a cavity wall? So if your home was built before 1930, roughly, there's a bit of kind of deliberation around this because it varies. But before 1930, then it's likely to be a solid brick wall. The exceptions can be if you're living in a coastal region or a kind of exposed area, say on top of a hill, and you get lots of driving rain, then you may have a very early version of a cavity wall to reduce moisture ingress into the home. The brick pattern, like we've already seen, is a common giveaway of the construction type. But usually, if, say, an assessment was being done and it was trying to be determined what the type of wall it is, it's usually determined by the wall thickness. So if it's a brick wall and it's over 260 millimeters thick, excluding any kind of render or cladding, plaster or anything like that, then it's likely to have a cavity. If it's 260 millimeters or less, then it's more likely to be a solid brick wall. So a key difference when looking at this and thinking about retrofit is the characteristics of each. So a solid wall is considered vapor open or breathable. So as I kind of hinted at with if you're in an exposed region and wanting to mitigate moisture ingress, a solid wall allows moisture to pass through it within and without, whereas a cavity wall has that cavity, so then any moisture from the outside will pass through that first leaf of brick and then drain out in the cavity rather than coming all the way to the inside of the property. So cavity wall homes are considered to be vapor closed, and you're not allowing that moisture to pass all the way through the wall. So in terms of cavity wall insulation, which is what many of you watching this may be kind of querying about or interested about, most cavities can be filled, but there are some exceptions. So let's kind of go into a bit more detail around that. So the times where you wouldn't want to be installing cavity wall insulation would be if on the wall there's any kind of frost or structural damage on the outer leaf in particular. So if there's any kind of spalling or cracking or any kind of structural damage of any kind, then it would be best not to fill that cavity as it could lead to kind of further unintended consequences. If there's any evidence of rising or penetrating damp, particularly in the inner faces, this can be quite a major issue, and actually adding insulation could end up making this worse. And also if the insulation just becomes damp and wet and soaked, then it's also going to not perform as well thermally either. If there's any obstructions in the cavity, this is also not going to be a great idea, and it's just generally going to hinder you from being able to install that insulation effectively if there's anything actually inside that cavity that would block the insulation filling the whole space, because you want that to be a consistent fill all the way around. Or in the very rare cases, and I'm only mentioning this just for the off chance that you live in a property with this condition, if the cavity is actually used as a source of combustion air for a flue for ventilation purposes, so if actually that air is a ventilating, say, some kind of stove or wood burning unit in your home, but this is very rare to see that. So a cavity can be investigated as to whether it's filled or not, or the condition that it's in, using a borescope. So this is where a hole would be drilled into the wall and a tiny camera is placed through that hole, so then you can see inside of the cavity. It's very straightforward to do, and it's a simple way to determine if you're really unsure whether it's solid or cavity. That's one way to do it. And if you want to see the condition, then this is a way to do that as well. And a covered wall insulation is often guaranteed for 25 years, depending on the manufacturer or the supplier. Some materials can last longer than that, however, even up to 40 years or more. So I know a few people that I've spoken to recently have said, well, I had cavity wall filled, but it was many, many decades ago now, and I'm considering what to do. Should I have it removed and refilled? Should I apply new insulation? How long does it last for? So that kind of answers that question in terms of the expected lifespan. And in terms of removing it, there's well, yeah, there is then two options there. Either you can remove it, which is quite an expensive job, and have it refilled, um, or you could then apply internal or external wall insulation in addition to it. But really, you'd be wanting to look at it on a case by case basis, depending on what is the current condition of that insulation inside of the wall. Like, is it best to just be left there if it's really, really old and deteriorated? Or would it be more beneficial for the overall health and fabric of the property to remove that if, say, the condition of the cavity fill is now leading to moisture ingress or tracking across the outer to the inner leaf or anything like that? So if you are concerned, it'd be best to speak to a building surveyor or structural engineer to investigate that more. I've added this image on the screen here, which gives a bit of indication around how coat walls can be poorly filled at times. So you can see from the thermal image, the areas in kind of green and yellow, showing areas where the actual insulation is not filled underneath that window or around the top of the window or in between them two windows that are quite close together. And that's where you're going to have a great amount of heat loss. So this is something that we may be able to pick up through a survey if we're doing one at your property, and it's good to know how well performing your cavity wall insulation is actually doing. So within this presentation, it's looking at cavity wall homes, not just looking at the wall type and what to do with the walls, but also just what you do with modern homes that are cavity wall construction in general. So we want to look at all elements, including windows, doors, roofs, etc. And here I've picked out a few things from really what the starting point is to when you're looking at retrofit, which is maintenance and repair, because there's no point trying to add loads of insulation or installing new technologies if actually your home is in disrepair and some basic maintenance work needs to be done to make sure that it's performing as it should do. So a few things that have been picked out here is seals around kind of doors and windows. As you can see here, a seal has deteriorated, which will most likely lead to drafts and air leakage. So your lovely warm air in your home is just being let out for your property through all these drafts. Then next to that, you can see the roof and there's some tiles that have slipped there. And you can also see right at the bottom of the image that the drain is also coming loose. So there's two issues in one. Water ingress that could be happening through the tiles, leading to, say, soaking your loft insulation and meaning it's performing less well thermally. And also the guttering there, which could mean that water is dripping down the walls and soaking through the brickwork. And again, it could lead to the walls not performing very well thermally and leading to moisture damage as well. Similar to that, on the bottom left, you've got an example of efflorescence, which is basically where salt deposits start to collect on the surface of a wall, where you've had moisture kind of penetrate or soak a wall and then evaporate again and leave salt to collect. The salt in and of itself isn't necessarily an issue, but it could be an indication that your walls are getting excessively wet, and that's a lot of moisture buildup. So it could be an indication that something needs to be looked into as to what the source of that moisture is. And then the final image at the bottom there is a blown glazed window, which again is showing that actually the airtight seal within that gap between the two glazing panes has failed and air has got inside, which means that there's a thermal bypass. Which essentially just means that the window is not going to perform thermally as it's meant to, as it used to. So more heat loss will be going through that window. So these are the kind of issues that you may want to be thinking about addressing. So key things to look at are, like I mentioned, rainwater goods, your roof, have any tiles slipped, how are the walls, what condition are they in, do they need repointing, is there any cracking or vegetation growth, and how your windows and doors, are any seals split or seals missing, have the glazing units failed. So these are really, really key things to address if you are aware that your home has any of these issues before considering any kind of deeper retrofit works. And the next thing I wanted to speak about is airtightness. So, some of you who are living in a cavity wall home may think, oh, well, I know that heritage properties are really, really drafty, and they're the only ones that need to concern themselves with airtightness with their single glazing windows and their old barn doors. Well, you'll be surprised actually how poorly airtight your kind of post-war cavity wall home could be, as there are so many ways that air leakage can occur. And this image kind of demonstrates a few of them areas, whether it's around windows, through floorboards, penetrations in the walls, like water pipes, even plug sockets as well. So airtightness is really, really key because you can put all the insulation in the world, but if you've got big gaping holes around your house, that is just air is just flowing through and letting all that heat out, then you're gonna be wasting your money, and actually be far better spent and time spent addressing your air tightness first. So you can test your air tightness quantitatively through a using a blower door kit, so doing an air pressure test. This is basically where a very large fan is placed on your door, and it's either pressurized or depressurized, and then it's tested as to how quickly that air in the property is either leaving or entering your home. And it can also be used as a diagnostic tool to identify where the drafts might be happening as well. So it's a great thing to be able to do. The March Energy Agency are seen to be offering air pressure tests, as we've recently purchased some kit. So do watch this space, as that service could be available sometime soon. You can also do it in a very low cost way by just feeling with the back of your hand on a windy day and seeing where drafts might be coming through, and putting your hand, say, next to where a window is, or kind of around the bottom of your door, anything like that, to try and identify where drafts might be coming through to be able to address them. But the usual suspects, like I mentioned, would be windows, doors, surface penetrations, etc. But don't confuse air permeability with vapor permeability. So air permeability is when there are kind of actual physical gaps around building elements where air is moving through, whereas vapor permeability is around how moisture tracks actually through materials. And aka we're talking about that breathability. So if you're, say, living in an older home in a solid wall and you're wanting to maintain that breathability, that's what we're talking about a vapor permeability, but not air permeability. So they are two different things. So again, this was an interactive exercise within the live webinar, but this is yet to spot the thermal weak spots that we can often see in modern homes. So I'll just go through them quickly. So the first one is flat roofs. These are quite commonly building elements that can be a real weak spot if they haven't been insulated at all or have been poorly constructed. So it's often a key one to address, particularly say if it's your kitchen extension and somewhere where you spend a lot of time in, as we do in the 21st century. It could be a really important one for your thermal comfort to address that. Then the middle image is the bay window. So obviously this is an area that's got a large amount of glazing, which can be leading to a lot of heat loss, but particularly issues around, say, the small area of roof right above the bay window, which may not be insulated, or even the walls around that bay may be of a different construction type. They may be solid while the rest is cavity, or it may not have been filled while the rest has. So there's a lot of reasons why bay windows can be a bit of a troublesome spot for thermal performance that needs to be addressed. And then the final image is integral garages. So again, you wouldn't usually be having a well-insulated and airtight garage. They're quite cold and drafty spaces, and it's quite often that the walls between the garage and the rest of the house may not be insulated, or even the ceiling of the garage and therefore the floor of the room above is not insulated. So therefore, it's letting heat out of your home. So again, that's an area that could be worth addressing if you have an integral garage. So, where you insulate, you must ventilate. So what we mean by this is when you insulate and improve the air tightness, and insulation often does improve the air tightness of your home as well, then it means that your the air change within the house is being reduced, and therefore less fresh air is coming in, as well as kind of having cold drafts as well. But obviously, we need fresh air because good quality air is very good for our health. I say very good for our health; it's essential for our health. So ventilation and maintaining that is really, really important. Obviously, if you've had quite a drafty home, then them drafts are acting as uncontrolled ventilation and to provide you with that fresh air. But what we want to do ideally is to have a controlled ventilation strategy or system. So rather than just having them drafts and kind of a changeability around how much air might be coming in and out depending on how windy it is or not. We would recommend having trickle vents in windows, undercuts under your internal doors to allow airflow, and then mechanical extractor fans as kind of a baseline. So having continuously running extractor fans in all the wet rooms, so that would be your kitchen, toilets and bathrooms. But the gold standard, if you really want to kind of go hard on your retrofit project, would be installing a MVHR or mechanical ventilation with heat recovery unit. So this is another whole house system which would basically have ducting to all the spaces in your home, extracting or releasing air as required and recovering the heat from that. So rather than losing hot air by pulling out stale air and taking it to the outside and losing all the heat with it, there's a heat exchanger. So all the stale air being removed from the home, the heat is taken from it, and then the fresh air as it comes in is being heated, so that heat is retained. So if you really want to go for it with your ventilation system with your retrofit project to completely minimise or as much as possible minimise your heat loss, then NVHR may be the way to go. But otherwise, mechanical extractor fans in the wet rooms is a good baseline. So now you've dealt with any remedials and repair work on the property. You've looked at the air tightness and improving that. You've probably already got some loft insulation, most likely in a more modern home, and your cavities filled. So you're thinking, okay, well, I've done all the fabric works to the kind of physical elements of the house. What's next? How can I further decarbonise? So the next step may be for you to get a heat pump. So you may have heard quite a lot about heat pumps. And we do have plenty of content and resources which give a lot more detail around these. But in short, essentially how they work is kind of like a refrigerator unit, but in reverse, because it has the refrigerating liquid in it. And essentially it's taking what energy there is in the outside air and removing that to then heat either a water system or an air system to then heat the home. And this runs on electricity. And for every single unit of electrical energy used, it can produce quite often 3 to 4 times that of the amount of units of heat energy. So basically, it's 300 to 400% efficient compared to a gas boiler that might be 90% efficient. So are they noisy? This is a big question that gets asked. So I've seen plenty of heat pumps in action in homes across Shropshire, for example, and I wouldn't say they're noisy at all. I mean, most heating systems will make some kind of noise, even a gas boiler on the inside of your home, and you'll hear a gentle whir while it's on over the winter months. And I think the key thing that I've heard from people that live with them is, say, in the kind of real coldest weeks of the winter, say the kind of couple of weeks in early Jan, where it's really, really frosty and it's -5 degrees, and the heat pump is having to work a lot harder, then it's a bit louder during them periods. But for the majority of the time, throughout the heating season, when you've got it on most likely continuously, it's not very loud at all. And to meet with standards, they can't be excessively loud either. They can't be any more than 42 decibels heard from the nearest kind of neighbouring window. So they're designed and will continue to be designed to be as quiet as possible. So are they expensive to run? This is another question that comes up. So with the efficiencies, like I mentioned earlier, if you compare it to gas, and many of you will likely have a mains gas boiler currently, you should be able to find parity with the price of gas that you're currently paying at the current kind of rates of electric compared to gas, and because of that difference in efficiency. So you should be paying, yeah, roughly the same amount. Obviously, if you go and embark on kind of further air tightness improvements and retrofit measures at the time that you install that heat pump, then you should then be able to reduce the cost of running the heat pump further. Are they expensive to install? So the price can really vary. Kind of rough estimate I've given there is kind of over £10,000, but it obviously hugely varies depending on the size of your property, and whether you need to do any upgrades to the current kind of distribution system, aka the radiators or underfloor heating, whatever you might have in your house, because as these heat pumps will run at a lower flow temperature compared to your gas boiler. So you might have your gas boiler set at 65 degrees, for example. Your heat pump, you'd be ideally running that at 45 degrees, so a lot lower temperature. Therefore, the radiators will be giving out a lot less heat. So you would ideally want them to be larger in size to emit a greater amount of heat. Over time, and obviously as you're running the heat pump for an extended period, you're basically wanting to go low and slow rather than how we're quite used to running our gas boilers of just kind of whacking up at high heat for a few hours, chucking out loads of heat and then turning it off again. That's not how you want to run a heat pump because it's not going to be efficient. You want to put it on continuously, low and slow, 45 degrees. But yeah, with that, you would ideally want kind of large modern radiators to compensate. So depending on how much kind of work around that to upgrade your radiators you might need, and the price will vary. But one benefit is that central government are running the boiler upgrade scheme, which will give you 7.5 grand towards the cost of your heat pump. So it could bring it down to say around kind of 2 to 3 grand potentially, which then brings it in a price that's very much comparable to the cost of a new gas boiler. So if your gas boiler is coming to the end of its life, then it could really be worth considering getting a heat pump without really much difference in cost to install, but making a huge difference to the carbon emissions of your home. So then from there, you might be considering generating your own electricity, and this could be through solar panels and battery storage. So solar panels will work pretty much on any roof apart from north facing. A lot of people think, oh, well, only if a south facing roof can I get solar panels. Even on east and west facing roofs, they can work just as well. I say just as well, obviously. Um, not to the same intensity, but they can still work really, really effectively. And if, say, you have a pitch which has aspects on east and west, and you have panels on both sides, then you get an even distribution across the day as the sun tracks across the sky. So it's still really, really effective if you've got, yeah, a south, east, or west facing roof. And they are cheaper than you might think. I remember a few years back, kind of learning about solar panels in kind of school and university, and it's considered a really, really expensive option. It was kind of £50,000 for a typical homeowner to be investing in solar panels, but now you could expect to maybe be paying kind of £6,000 to £10,000, depending on the amount of panels that you're getting and the size of the array. So it's really, really affordable now, and considering the savings that you can get for generating your own energy, as well as exporting it back to the grid for any energy that you're not using through the smart export guarantee, it can really be a no-brainer. And when you combine that, say, with a heat pump, if you've installed one of them, and battery storage as well, and have a time of use tariff that more energy suppliers are providing, if you have an electric vehicle, for example, then you can see some really significant bill savings. We've seen some studies done by other partners of ours that have modeled like 85% bill saving through this kind of method. So it's really, really impressive what can be done if you're willing to kind of invest in green technologies and go the whole hog. In terms of planning permission, um, you should be able to get permitted development in most cases. If you're in a conservation area, the key thing is to have it out of view of the streets, because conservation areas are all about maintaining or the upkeep of the streetscape. So if you can put it on a rear roof that's out of sight, then usually permitted development rights would apply. But obviously do check in with your local planning officer to check on with this. So In terms of any grants that are available, in case this is relevant to you and you're thinking, well, I'd love to do this, but I just simply don't have the capital, the money to spend on this. And there are some grants that are available. And one that is running at the moment is the ECO, or Energy Company Obligation Grant. This is for people that are kind of vulnerable households or on lower incomes to be able to access fully funded retrofit measures directly through installers. So the criteria are that either your household income is £31,000 or below, and that your household EPC is a D to a G. Or if you have two proxy routes, which could be receiving a tax rebate, or your house is eligible for free school meals, or something similar to that, some kind of means tested benefit, then you could also be eligible through that route if you're able to provide evidence for it. Or thirdly, if neither of them apply, if someone in the property has a long-standing health condition that would be exacerbated by living in a cold home, and you can have a doctor's note to give evidence for that, then you could also be eligible by that route as well. So there's a few different ways that you could access this funding. And if you want to find accredited eco installers, then our recommendation would be to go to the Trustmark website. Trustmark is a government endorsed accreditation body, and they basically give their kind of seal of approval for businesses to operate on these kind of retrofit grant schemes. So if you go on their website, you'll be able to find local businesses and get in touch with them, and then they'll be able to basically get the funding themselves and apply for it on your behalf in that sense. So you're not having to deal with the finances around it. You just receive the funded measures, whether it's solar panels or insulation or whatever you've been interested in applying for. But if you would like some support around that, do get in touch with us through our project. If you're in Derbyshire, that would be Warmer Derby and Derbyshire. Or if you're living in one of the other areas, you could contact Keep Shropshire Warm or Telford Energy Advice. So once again, just a final reminder, if you are listening or watching this before March 2025 or before the end of March 2025, we do have a package of support to do an in-depth and bespoke retrofit assessment and report for you to give recommendations on what retrofit plan you could do for your home. So if you are interested in that, then do get in touch, go to our website and apply for that online. But that is everything. So thank you so much for listening to this presentation. If you do have any questions and want to get in touch with us, then you can do at wdd@mea.org.uk, or you can call us on the number on the screen there. If you are listening to this or watching this and you're actually based in Nottingham and want to speak to Nottingham Energy Partnership, then you can get in touch with them through the details on the screen there as well. And if you're listening to this or watching this and you are based in Shropshire, Telford, Wrekin or Herefordshire, then we have a project similar to the Heat Hub project called Futurely Homes. You've got the website link on there, so do get in touch with us through that project as well. Thank you so much for listening. If you have any questions about the webinar or any other retrofit advice that you'd like to go and do get in touch. Thank you.